All right, and welcome back. Hello again. This is a conversation. We're just talking. It's about a robot hand, a human mimicking robot hand. This is a well known demonstration of physiology where if this person, the green person, says, "Look, I got a dollar bill," to the purple person, you put your hand right there. Don't touch the dollar bill. You just put your hand right there. And when I let go of this dollar bill, if you can catch it, you can have it. And what goes on is the human of the purple person has to see the dollar bill start moving, decide that's it, send the signals to the muscle center. The muscle center has to send the signals out down to the hand to squeeze the fingers together. And all of that processing is physiological and takes a certain amount of time. And what happens is the dollar bill will go right through their fingers and they won't catch it. And you're like, oh, come on. But it's true. You have to set it up right. I mean, there's a lot of things you have to do. One of the things that helps a lot when I've done it is to continue the conversation in a way that's either weird or distracting in some way where they're not paying total attention, and that's when you let go of it. Anyway, I thought that was kind of pretty, but we're going to use our time, I hope, to do some moving around in SketchUp. So it's always nice to start with something like this. So we'll do that. And again, hello and welcome, and I'm glad you're here. I am glad you're here. We're having some fun. It's a conversation. We're just talking. I do have a YouTube channel. I have a website. And the page is discussions about a robot. Give the robot a hand. These are some of the points I wanted to mention about the hand of a robot that I think is reasonable for a human mimicking hand. And I always want to add this because any physically real item has the potential to hurt somebody. My advice is if you are managing a physically real item, you should manage it in a manner that is legally allowed and reasonable and safe. And if you can't manage it in that way, my advice is do not create it as a physically real item. And this includes particularly this hydraulic type stuff. It can sneak up on you. All right, let's go back over into SketchUp and we'll do some drawings with this hand. All right, and we're going to do some work in SketchUp. But the first thing I wanted to do, I took my own hand, and I got to get everything straight here. I have a little crease in my palm right there. So I measured the distance from the metacarpal phalangeal joint down to where that crease is. And that value came out to 82 millimeters. And then I measured the distance from my proximal interphalangeal joint to the metacarpal phalangeal joint of my index finger, and that came out to 45 millimeters. Then I put my hand up here and brought my finger down a reasonable and comfortable amount, and I measured the distance from the proximal interphalangeal joint over to that crease. So that's what I did. And let's go see what that looks like in SketchUp. And this is the drawing that I got. And so here is the proximal interphalangeal joint. This is the metacarpal phalangeal joint, and this is that little crease in my wrist. And the distance from the crease in my wrist up to the metacarpal phalangeal joint was 82 millimeters. And the distance from the metacarpal phalangeal joint to the proximal interphalangeal joint was 45 millimeters. And the distance from when I tilted it down from the proximal interphalangeal joint back down to that little crease in my wrist was 108 millimeters. And so we can put a line on here. And we can get the protractor, and that comes to, and I'm reading it off the bottom there, 66.5 degrees. And all I can say to that is, what? I mean, huh? But that's what it says. And what's interesting with Google AI, I found if I keep asking the same question to Google AI, I get a different answer each time, which is, does not make sense to me. But it said once that it was 50 to 60 degrees. And I just don't know. I don't know. But anyway, that's what happened with my own hand that I carry around with me, 66 degrees. So we're going to work with that. And if we back out of this, we now see that hand, okay? And this hand here is just the hand sticking up. That's the little finger, and this is a complete copy of it. And so we're going to take this little finger and we're going to flex it down. And the central processing unit of the computer is running the recording program and the drawing program. So sometimes things kind of get bogged up, and we're just going to have to see what happens. And we'll start by going down here and going down into the groups. Okay, and the group that we have right now is that little finger going down into the metacarpal phalangeal joint. Let's see, we want to back out one. Let's put it right there. Yeah, there it is. So there's all of the little finger, but it's not including the base of this cardanic joint or this metacarpal phalangeal joint. So we're going to take, now I put these triangles in here. SketchUp will connect the rotation device to a vertex. And if you have a plane of a triangle, like a triangle or anything that's a plane, it will adjust the rotation to be congruent with the plane. So we'll put it there. And we will tilt it down. Let's go down by, say, 70 degrees. And I can just type in 70. And there it is. And so we have started. And my assistant will say, Dr. Gray, this is crazy. You can't do that. You can't have these sticking out like this. And my reply is, well, just slow down. This is the anchoring point of the cardanic joint for this hydraulic cylinder on this turning or plate that turns the finger for abduction, abduction, and flexion, extension. So we want these to travel with it, and they did. And so what we want to do next, having done that, these are where they're supposed to be, because you can see they are bolted in place. Okay, there's the bolts that bolt these in place. Okay, so what we want to do at this point, and I will just see how fast this goes. Sometimes it works and sometimes it doesn't work, but we can select this end of this hydraulic cylinder and the piston rod, and it is in this holding structure. Okay, and so we can go up there and get to this triangle. We're on the vertex. And we can rotate that down to there. And again, my assistant will say, well, Dr. Gray, that's crazy. This thing's not supposed to stick down there like that. The reply being, I know, take it easy. We do want to go, so we have a copy, so we can go over here and look at the copy, and we can see that this base of this hydraulic cylinder is up against this edge of this upper plate. So we can go back over here to this. One of the advantages of a polygon-based drawing program is you can ask to see the hidden geometry. And so these are congruent with the axes of this hydraulic cylinder. So we can put an indexing line on that, and it's properly oriented for this device. And now we can select this hydraulic cylinder and this whole cardanic joint. And I think sometimes it works better if we are in the same plane. So we've picked another indexing line, and what we can do is grab that and just ease this back up, and we're easing it back up in a manner that's congruent with its planes and its axes, and we can just keep easing this back up like that. And now we've got it back up here where it's supposed to be, which is great. Okay, and it looks like it needs to go up a little bit more. A problem with this program is that it helps you by deciding what you want to do. And it's not what I want to do, but it thinks it is. So now it's up in the air a little bit, but it has moved over this way. And so we can go back down here and select all of it, and we can take the rotation device again and go up here to get it on that vertex of that cardanic joint rotation point. We can come down here and we can do a little bit of movement to get this, and I want to go a little bit past it, and I'll show you why. Because we want to take this support structure for this cardanic joint, which is that, and we'll put the rotation marker, because this is another place where it can rotate, and we'll try to bring that back down to being parallel like it's supposed to be. And then we can come back out and grab this hydraulic cylinder and that, and we can put the indexing line in there. There it is. And we can grab this again. It's helping me. I wish it would not help me, but it's helping me. And it's deciding that I wanted to grab something else, but all I really wanted to do was grab this and we'll see it. See, it's little, when it's a little red square like that, that means that you have what you want. And see, there's nothing back there, so now it's behaving itself, and we can bring it down. Now, it went to 0.5. I can just put in 0.1 or 0.2. Sometimes you have to do it this way. It's just not going to let you move it by visual. There, 0.3. So that's not so bad. And we'll go back up here, and we can see that we've got this back where it's supposed to be, which is great. All right, and this other one can be swung down in the same way, but I just don't have time to do that. I wanted to go slowly and make sure you saw what happened. But what's going on is this, in order to bring this to the straight up area, you can see where these piston heads are in the hydraulic cylinders, and to generate the flexion down, this one moved way down, this one moved a little bit. And what is important, what we did is we moved the finger and let the hydraulic cylinders catch up. The truth is, in the real world, the hydraulic cylinders will move their piston rods and the finger will follow along. But I just wanted you to see that, and we're trying to make a hand that can do this kind of stuff, and we'll see. Okay, a quick hand performance for you, like that. This is so counterintuitive to me, but there we go. That's what we want a hand to do, to look like this.